Hi everyone, my name is Tiago Rodrigues, I'm an OutSystems architect, and this is my fifth video of OutSystems and AI, and this time I will be showing you my last pattern of this current series, the pub/sub pattern. So in this video it will be a more short video like the previous one. So we will start by doing a quick review of the previous patterns that we presented here, and I'm going also to present the new pattern, the pub/sub pattern. Then we will also explore a bit how can we improve this pattern and scale this pattern by using also the router pattern with it. So a combination of a publish subscriber and a router. And we will end this video by showing a demo of how we can implement in OutSystems the two variations that we will be talking here. So just the pub/sub and also the pub/sub using a router before. So let's start. In the previous videos, we saw three other patterns. So we started with the orchestration pattern, where we have basically a central node that has the knowledge to manage the flows and to manage the steps that it should perform. So this is a lot used when you need to have a central role that decides on each step who to call to receive the result and to process the next step. So you might see in this pattern that the results always goes back to the central node, and he is the one deciding if the process should continue or if it should end. So this was our first pattern, sorry. Then we have the collaboration pattern, where we don't have in here a central node. So we have a group of agents that can be one to many, and we can have different iteration cycles between them, but the goal here is to make the agents each one perform a specific collaboration task where each one is an expert or on a certain matter. They perform their task, and then the result is used in a collaborative way between all of them. So depending then on the variation, we may have different ways to apply this collaboration pattern. Then we went to the router pattern, where basically the router pattern is a pattern to help classifying and redirect the messages that come to specific paths. So despite this being very similar to the orchestrator pattern, it's very different, because first the router his only job is to read the message, the incoming message, and decide where to send, and afterwards the process continues and doesn't go back. So it's just a redirect pattern. And now we have the new pattern, that is the pub/sub pattern, or the publish subscriber pattern. This is this is basically based on the publish subscriber architecture, an event driven architecture. And in here, the goal is to have a queue of messages. So the first big characteristic here is that there is a barrier between the publisher and the subscriber. So in the previous patterns, the central node was always connected with the other. He was the one responsible for calling them. But in here, we have a message queue in the middle. In this message, a queue, what it allows for a publisher to put messages there. So the publisher is the node responsible to receive a message and put the message in a message queue. And then we have the subscribers. We can have many subscribers that their goal is to read the messages from the queue and process. So let's analyze here some advantages of this pattern. First, I think it's the biggest advantage of this pattern is that, as you guys may see, this can scale in terms of creating and removing subscribers in a much safer way because it does not affect the rest of the subscribers or the system. Let's imagine in this image here that the subscribers see it's a system that is deprecated, it's no longer used, so we will remove this subscriber, so we can immediately remove it. That because we have a queue, the subscriber A and B will continue to read messages from the queue and the publish will continue to put messages there. So the fact that you scale by adding and removing subscribers or publishers, it does not affect the whole system. So it gives great flexibility in updating the pattern with more subscribers or more publishers. So this is for me one of the biggest advantage. Another situation here is that you might think, why is it necessary to have something so complex as a queue and the subscribers, right? Why can't we just have like a router where we check the message, we process the message, and then we send it to the correct subscriber? And the answer is basically a set of small advantages in the typical publish subscriber pattern. So this is not something from AI, this is something from already the pattern that exists quite some years ago, that is this pub sub. So by using this system, first you can control better the incoming of message, the load, because we have a queue here. So it means that if by some reason the subscribers are busy doing a process, doing something on their own, you can continue, the publish can continue to put messages in the queue, and the subscribers with their own pace, they will get the messages from the queue. So this means that the publish and the subscribers, they don't need to wait for the messages, or they don't need to wait that each one is available, because each one can on their own pace process the messages. So it's better for a system that is expected to receive a lot of messages, and there is the need to have this space on the subscribers to read them and to process them. Another characteristic here in this system is that, as you guys may see here, we have different subscribers, and they should not depend on each other. So the fact that each subscriber is doing a task, those tasks should be completely distinct from the different subscribers. For example, they can be different systems, completely independent from each other. Imagine that the subscriber A, his goal is to send information, to process it, send information to Dynamics. The subscriber B is to process it, send information to an HR system, and the subscriber C is an agent that is responsible to send emails and schedule calendar events, for example. These three should be completely independent from each other. First, because it's a better design for each one to retrieve the message and decide what to do, and they don't need anything else besides the message to perform that. But also because of a very important characteristic here is that you cannot determine the order that each subscriber will fetch the messages. So this is a queue, the message is put it there, and then it is up for each subscriber to decide when they will fetch the message. So in one scenario, it can happen that you put a message in the queue, and the subscriber A reads it first by chance, then the subscriber B, and then the subscriber C. But you can have then a second message put it, and in this case, because the subscriber A was still a bit busy, or it took more time checking the message, that second one can be read and processed first by the B, then by the C, and then by the A. So this means that because it's such a random situation, which subscriber is going to read first the message, you cannot create connections between them. Because let's imagine that the subscriber B would need to wait for the subscriber A, or to have some information that results from the process of the message by the subscriber A, right? So if that happens, the subscriber B would have to wait for the A to finish. In that case, this pattern is not the best solution, or if you really want to do this, you need to build here some variations where the subscriber B, for example, gets the message. That's okay, he gets the message, but then he has his own verification to see when the A finishes, and then he combines and continues the process. But that should not be the typical design of a PubSub system. A PubSub should always have subscribers that are independent from each other, and they can do what they need to do only by the message content, and this is the characteristic. So for agents or for AI, this pattern can be very useful when you may have different contexts of information coming to the system. So you can have messages from all sorts of purposes and context, and you need to have a pre-processment of the data to make it from an unstructured message to a structured object, and then perform what it needs to perform. And this is something that the AI, this pattern with AI can help. So it can have a publisher that processes the information, puts on the queue, and then the subscribers, they also have agents deciding if the message is important for them or not, and what to do. So this was the introduction of the publish subscriber pattern. But in this case, we might also have a variation. And that's what we are going now to see, is what do we get when we combine this pattern with the router to improve the classification of the messages. So let's see this pattern. The combination of the PubSub pattern with the router can have here very many advantages. Because if we look into the previous pattern, let's analyze a bit more how this can be made with AI. So imagine you have a scenario where different types of messages come in. Okay, so we can have, imagine for example, conversations on Teams. So imagine we have a system that reads messages from a bot on Teams, an AI bot, and it triggers this process flow. So we can have employees on a company going to the chat on the chatbot on the Teams and say, hey, we have a new employee coming up next week. His name is John Doe. He will be working for the IT department. Or we can have another person saying, hey, we have a new project with this client. The project will last or will start in this day until this, and the team, it will be this one. Or we can have many other types of messages that they are plain text messages, so they are not structured. And so for that reason, there is the need of understanding this, of understanding the context of the message. So if we have this pattern here, and let's consider that we have here an agent that is the Teams bot, and what he does is every time he detects that there is a message of something to trigger an action, he puts that message in the queue, right? And then the subscribers get the message. If the subscriber A imagine, is the HR system. The subscriber B is the marketing system, or a sales system. The subscriber C, imagine that is a financial system, right? If we have these three systems, not all of them need to act upon every message. Okay, so we might have, for example, if the message is we have a new employee coming up, the HR, probably the HR system wants to trigger the process to create this employee in their system. The financial probably also wants to trigger something to make to create the financial record for this new employee. But for example, the marketing or the sales application might not want to do anything with it. Okay, so this means that there must be, if the message here is always put it in plain text, there must be in all these subscribers, there must be an agent that reads this message and classifies if this is something of interest for this system or not. So in here we would have an HR agent that would check the message, and he would say, oh yes, this is an employee registration message, and I've already dissected this into the following structure. So the employee name is this, the employee department is this, the start date is this. So it structures the data according to what it's necessary to be done, and then it processes. So with the current situation, it's basically up for the subscribers to read generic messages and to understand if this is something for them to process or not. And you guys may see that this can be a helpful situation, because it is up for the ones that receive message to determine if it is of interest or not. But for bigger systems that can process all types of messages, this might be a bit overkilling, because you might have all subscribers. Imagine that you have 20 subscribers, all of them will be triggered to understand the message, and so this can lead to a lot of overload of processment. It will be costly, and in the end you are basically throwing away a bit of processment, because probably not all messages will go for all systems. Okay, if that is the case, then no problem, but in here it can be a disadvantage. So if you want to scale the queue, or if you want to give a better redirection, you can then create this combination of a publish subscriber with a router pattern. And how does this work? Basically, the node that is before the publisher node, the one that puts message on the queue, before he puts a generic message, he does the router pattern to classify the message. So we can train him to do a pre-processment of the message and to already put a type in that message. So this is a very common thing in published subscription architectures, that you can create a sort of a message type, and depending on that type, it only routes, or it only certain subscribers process that message. So in this case, imagine we have a system that receives messages, full text messages. So this publisher dash router, what he will do is that he will read the message, and then he will decide, is this a type X message, a type Y, or a type Z. And depending on the result, he puts the message on the queue, but he already labels the message with the type that it has. And the advantage of this is that you can already have the system configured so that the messages X are only sent to subscriber A and subscriber C. So this already pre-filters the subscribers that get the message. And the biggest advantage of this is that you redirect better so it's a more efficient process. But at the same time, if there is already some pre-processment of the type of message, for the agents, they can already process the message knowing that they will extract results based on that message because it has that specific type. So the subscriber A knows that if the message type X is an employee information, he already knows that in the message there will be some information of that employee, so he can act upon that accordingly. So by using this combination of having a published subscriber with a router pattern before, it becomes more efficient to scale the pattern to more subscribers or to more publishers. You can even have different publishers also putting message on the queue, but it allows you to better scale and maintain a bit more control of who gets what messages, so it doesn't become such an overloaded process of everyone listening to all the messages. So this is very handy, and we are going to show, or we are going to see how we can use both of them in OutSystems, or how can we implement both of them in OutSystems. In this case, this pattern here, because we already created a router pattern in the previous video, so in this process here we will already put structure message in the queue, so it will already have a structure defined type, so we will see how more direct is for the subscribers to process that message. So let's see this on OutSystems. If we want to implement a pub sub pattern in OutSystems, there are some things that we need to know beforehand. And in this case, what I did was I implemented very simple 3 applications. One application is basically a queue list where I basically generate messages, and I can do it or generic messages, or in this case already a structured message, just to test the second scenario that I talked before. But in here it's very simple. I just throw a message here and I send. And then I have 2 other applications. One, it's an HR system that basically has the employee list and already has here 1 employee, and we have also a financial system where we also have here some information of that is important to know about employees. So these are the 2 systems, and both of them they are specified to receive information from employees. Now you may ask something like, okay, but if we have a publisher, a queue, and the subscribers, this means that we need to implement also in this in OutSystems. So we need to have the publisher, that is basically the application that I showed with the message, but we need to implement this queue, right? Because there is no way for the subscribers to get a warning about this. But that is not quite true. And the reason for it is because OutSystems already works with this type of architecture. So in reality, when we are developing events in the Service Studio, so when we have this type of events, OutSystems has its own, under the hood, it has its own queue that processes these types of events, of these types of triggers. So every time we have this and we call somewhere the trigger to perform this, so when we do this, OutSystems doesn't immediately start the event and runs the logic. What it happens is that OutSystems has its own queue where it receives the trigger of these events, and then he processes the message. So if we look into the events and then the workflows that are triggered by the events, it already implements under the hood a pub/sub architecture. So this is the way for OutSystems to allow us to develop pub/sub patterns with or without the usage of AI. So this means that we do not need to implement anything of that architecture on our side because OutSystems is already built for it. And that saves us a lot of time. So another thing that you might ask from this is, oh, so if the workflows and the events, they use a pub/sub pattern, and if in the other previous patterns, the router, the orchestration, you used workflows, so it means that it is a pub/sub pattern. Yes and no. So in a certain point, yes, I used a pub/sub mechanism to trigger the workflows, right? But the pattern that I was trying to showcase, for example, in the orchestration pattern, we might see that what triggers that process is an event. So like all the other workflows, it's triggered by an event, but then the process is made with a workflow. So after this, we are talking about the subscription part of the pattern of the pub/sub. So in reality, what I'm showcasing here is what happens after receiving a message. So in reality, this pattern does not use a pub/sub, it's after the pub/sub. So we have here the pub/sub effect happening, and then we have the orchestration pattern with the different scenarios. The same thing with the router. The router was triggered by an event, but then everything else was made on its own. So this means that yes, every workflow in OutSystems is triggered by a subscription, by the trigger of an event, but it doesn't mean that everything that comes after belongs to a pub/sub pattern. This was just the way the events and the workflows communicate with each other. So what makes then here the pub/sub effect? And let's then look into the ones that we have currently. So we have the queue, and in the queue we can put a message. Let me just select this one for us to see it happening. And let me put here, so his name is John Doe. For us to test with a different one, it will be joining the marketing department, has a junior consultant. Okay. So we saved this message. If we go, if we look into the message queue, we see that the only thing that we are doing when we create a message is triggering an event, and we trigger and we send the message as it is, the full message. So the event is this one, and you see that in here I'm not doing anything else. So if we check the generic trigger, it doesn't have any handler, so it means that it's in this application this ends here. After doing the trigger, goes to end, and that's it. So what this application is doing is publishing the message. He is publishing, triggering the event, so publishing an event to be triggered. Where does the subscribers reside? They are here, not completely here, but they are in the other two applications when we see these service actions. So we have here the service actions where we say have here subscriber message handler, and then we basically call the module we call here the module just to check if the message is indeed an employee registration message, and if it is, he structures the parameters with what we want. So after that, we just need to save the arguments of the function and create the employee. But so far, I'm not triggering anything here. This is a service action, so it will not be called by herself. So what this is where the workflows come in. Because right now, if now I go to the workflows, so you can see that I have here these two, the HR system employee registration, the HR system message process, and the financial system employee registration, financial system message process. And the reason why we have these is because I've created two ways, with a structured message and without, just for us to see the difference. But for now, let's keep up on the message. So on the message process, if we go inside this workflow, we have a very simple workflow. So it's not almost a workflow at all. It's simply a trigger. It calls the subscriber and it ends. So what is the characteristic of this scenario? The characteristic of this scenario is that we have this financial system message process listening to the generic event trigger. And if we go back and we open the HR message process, we also have the same trigger being used as a trigger for this workflow. The same event being used for the trigger of this workflow. So we have two workflows that call actions in different applications. So this one, it triggers a message, a service action from the HR system, and this one triggers a message from the financial system. But these two are triggered by the same event. So what we have here, we have this scenario where the HR system is, for example, a subscriber A, the financial system is a subscriber B, and both of them are triggered by the same message. By the same event that basically is a message under the hood made by OutSystems. So the way we implement a pub sub mechanism in OutSystems is basically just as simple as creating an event, triggering that event when we need to trigger it, and then having the specific workflows calling or being triggered by that event. And this way we make sure that each one of them gets the information. So this is basically a generic pub sub. So far we didn't talk almost anything about AI. So now let's check the AI part. Because as you saw, in this queue we are sending generic messages, right? We are not classifying these messages. So it means that if we are sending generic messages and there is no pre-processment before the message, it means that all the subscribers will receive that message. And because they will receive that message, they will have to check on their side if that message is for them. That's why we have in the Service Studio, we have this call module to verify if the message it is indeed an employee registration message, and if so, it dissects the full name, the citizen ID, the department, the role, the tax code, and other parameters. So this means that right now we are implementing this scenario where the messages are put as is here, so the publish doesn't have almost any job at all, and all the subscribers are triggered, and then it is up for them to analyze the content. But we have talked about the combination, the possible combination of using a pub sub and a router. And so in this case, what would happen is that the publisher would pre-classify a message based on the content, and he would decide what type of message we are talking about. And so when he puts the message, he can already say the type of message that we are talking about, and he can also, if we want, to structure the information to be presented more in a structured way, like a JSON format or something like that, instead of free text. And with this, it's already possible for us then to say, okay, if a message is of type X, simply call the subscriber A and the subscriber B, not a C, not a B. So what does this reflect in OutSystems? Again, going back here to OutSystems, if we look into the workflows, this means that the OutSystems has under the hood there its own queue to trigger events. But if OutSystems has a queue, does it mean that that means that all the events will follow into that queue? So if we here have different events, right? Because I have currently in the workflows, I have different triggers, right? If I go to this one, it's generic event trigger. If I go, for example, to the orchestration pattern, we will have another trigger. So there are different events. So can we look into the different events as a type of event? And in my opinion, yes. You can see here that this one starts with start ticket process work. So this means that we can use different events to symbolize different types of message process that we want to have. So in here, in reality, instead of looking into type X, type Y, and type Z, we can look into event A, event B, event C. And what we do in this case is using the same pattern as we learned in the previous video, we can first detect what type of message are we talking about. Is it the employee registration? Is to schedule a meeting or send an email? Is to create a new project on Jira? So depending on what is requested, we can use first this router here, so that when he calls an event, he already calls a specific event we want to do. So in this case, imagine that for the scenario we are looking in this message queue, imagine that we would already have a trigger called employee registration. And in this case, it already receives the information more structured, so it's easy to be fetched by the systems, the subscribers. So this employee registration, in this case, I did not implement a router pattern because we already did it on the previous video, but you could imagine that what would happen under the hood would be that there would be a router that would receive this message and he would convert it to something like this, and then only after he would trigger the employee registration. And by having different triggers, imagine that we have this employee registration, then we could have also the schedule meeting one. We could have also the create project. So we could have all types of different events. We would have a router first deciding which one it would be called, and then on the portal side, we would then create a workflow per subscriber that we want to receive each one of them. So in this case, we would have a workflow, for example, for the HR that would receive the employee registration. We would have the financial and so on. And in this case, we could already have the information well structured, because in this case, when we receive this employee registration, we already receive this data. So the process is easier. We can see here in the studio that if we go to the HR and we call this new employee registration, it doesn't even use AI. And the reason for that is because it's not necessary, the data already comes structured. Of course, you could do other things afterwards with AI, but the fact that you pre-process the type of message before, it takes the responsibility of the subscribers to understand the message context, or it doesn't make it mandatory. It can still happen if you want to retrieve other information, but it doesn't make it mandatory. So these are the two ways you can use a pub/sub pattern. So, or you can consider that there is only one generic message handler, and then you could put all the all the applications that you want to listen to this event doing all sorts of things, including verifying the message, if it has interest for them or not. Or if you want to really scale and have really different types of messages that can trigger different subscribers, and you want to save resources, in this case, you can then create different patterns for each type of message, and then you will build your workflows only with the ones that you need, with the subscribers you need in each one of them. So this is basically the way you can develop a pub/sub pattern here in OutSystems. I think it's one of the most interesting patterns to look in terms of an architecture. It's very interesting, and it's one of the fastest to implement in OutSystems due to the fact that OutSystems already uses an architecture like this under the hood. So we are most of the times we do not even notice that we are using something like this. And yeah, that's it. This finalizes the 4 multi-agent system patterns that I wanted to talk about in this initial version. Of course, there are many other patterns. There are smaller concepts that you might or might not call patterns. For example, sequential action, a parallel action, the summarizer, or summarizer, yeah, the opposite of the router. So there are other patterns, and I do believe that due to the fact that this is just such a recent topic, I do believe that this will grow up, and there will be more variations of patterns to do and so on. But for now, I will leave with these 4, and next week I will be exploring other topics also related with AI, for you to also be aware. In this case, what I have in my backlog is to showcase a real-time API. The real-time API is basically an OpenAI API where you can have conversation with multi-channel at the same time, writing audio and function calling at the same time. So this is very handy to create like assistants in OutSystems that can guide you through a web page. I will show how. I also have in my backlog to talk about the computer use implementation. So how can we integrate OpenAI with an external system that has remote VMs to go through a computer and do certain actions and then return the results. And other ideas will come. I hope you guys enjoy it. Again, feel free to add comments. Feel free to even to question this pattern and to challenge me regarding the way OutSystems does this. So feel free. I'm very eager to know if this is in fact what happens under the hood in OutSystems, the way I explain it. So feel free. Hope you like it, and see you next week.